We have rectangular sheets of metal. So what would you probably do? Draw a rectangle. Such that the length is 3 times the width. So I don't have to label my sides x and y. If my width is x, what would my length be? So far we have a rectangle and we've labeled our sides. Equal sized squares measuring 5 inches on a side can be cut from the corners, so the resulting piece can be folded into a box. So equal sized squares are going to be cut out of the corners. So I'm going to go to every corner and cut off an identical square. Pretend those are all the same. If you need a visual, I have a piece of paper. That's my rectangle. Okay? I am going to cut squares off all my corners. So I'm not measuring right now, but let's just pretend. So I'm going to come through and cut a corner, cut the squares off. Okay. So once I cut off my squares, my thing looks like this, right? And then I'm folding those tabs that I just created to make a box. So if I fold each of those up, then in theory, if all my squares were truly identical, we have a box where all sides meet. Does that make sense? So I'm taking this sheet of metal, have to cut off the squares, and how big were they? 5 inches on a side, so it's a square, they're all the same. And then I fold up those tabs to create a box. So there's my box. Just fold it on these lines that were left. All right, can we make dimensions on this box? So this width was x. Okay, it was x across the side of my paper. But then I came and I cut 5 off this end and 5 off this end.
So x minus 10.
Yes, it was x, but I took 5 off each end, so I've removed a total of 10. My length was 3x. But when I fold it up, I've removed 5 off the left and 5 off the right, so now it would be. When I fold my box, the height of my box is the side of that square. So how tall is my box? Can everybody visualize what happened here and how I got those new dimensions? If the volume, how do you find volume of a box?
The length times width times height.
The volume is 1,435 cubic inches. So 1,435 equals, I'm just multiplying these, 5 times x minus 10 times 3x minus 10. Okay, this is the equation I need to solve. We could you guys care if I just divided by 5 on each side first? Give us some smaller numbers. Cancel those. 1435 divided by 5. What do I have to do with my x minus 10 and my 3x minus 10? So we get 3x squared minus 10x minus 30x plus 100. Set it equal to 0, combine all of our like terms. All right, now what? Check and see if we can divide all of our numbers by 3. So but it doesn't work with the 40, so we can't do that. So instead, we'll just do flip inside. Right. Find me a number that goes into that. We need two things that multiply to a negative 561 and add to a negative 40.
5111. Negative 51.
So we divide our 3 back. 51 divided by 3 is 17. Set those to 0 and we get 17 and negative 11/3. Okay, are both answers reasonable? No. What did X represent?
X represents the length of the part of the box, which could not be opened.
It was originally this piece of metal, right? So it can't be a negative. In fact, how big does X have to be? It has to be bigger than what number? 10, because I cut 5 off each edge, so it had to be bigger than 10 to start with. So that one's out. Then we answer our question. It wanted to know the dimensions of the original metal. So the metal was 17 inches by 3 times 17, 51 inches. Any questions on that? I want to put another one up here and see if you guys can set it up. So it's very similar. Take time to read it and see if you can draw the. Okay, so what we know, we have the same type of scenario, but we're altering the original metal. So we have a rectangle, but now the length is twice the width. So do I know what my width is? No, that's X. My length is twice that, so it would be 2X. Then I come in, trying to make a box out of this metal, so you have to cut the corners off. Okay, so think about when you cut those off. Just like I did with that piece of paper. I'm cutting those off, so I'm creating little tabs that then I can fold up. So I create a box now when I fold it all up. Okay, this side was took off how much from each end? 10. I took 10 off here and 10 off here, so it's x minus the 20 that we removed. This side was 2x, but I took the 10 off here and the 10 off here, so it's 2x minus the 20 that we removed. And when I fold it up, the height of the box is this length, which is 10. So now I want the volume, and we know that's just length times width times height. So if I take 10 times my x minus 20 times the 2x minus 20, it equals the total volume, which was 7,500. So first thing, I'd probably just divide the 10 over, give me smaller numbers to work with. And then we can FOIL. So we get 2x squared minus 20x minus 40x plus 400 equals 750. We subtract over the 750. Okay. What can I do this time?
Divide by 2.
So I need two numbers that multiply to a negative 175 and add to a negative 30. You want a cough drop? We didn't do slip inside, so I don't have to divide anything here. So x is 35, negative 5. Are both answers reasonable? Nope, it's got to be the 35. This time, I asked a different question. I said, find the dimensions of the box. So, if x is 35, 35 minus 20 would be 15 centimeters by 20 times 35 minus 20, 50 centimeters by my height was 10 centimeters. Length times width times height. 15 by 50 by 50. Any questions there? That is all that I really wanted to do today. So there is a handout posted on Classroom, very similar to the ones we have been doing. So some of the questions are like the last handout you turned in. There is one of these on here that's really the only new piece from today. So you have quite a bit of time now to work and hopefully get that done so you don't have to